So the presentation on prebiotics, how they work and the impacts they have on health will be split into two parts, presented by myself and Koen Venema. I want to start by making you think about this question. Which of these could be classed as a prebiotic? A milk-based product containing live bacteria, a refined sugar consumed as part of the diet, or an indigestible dietary carbohydrate? Although most people know what a probiotic is, with an example being answer A, fewer people know that a prebiotic is not answer B, a refined sugar, but is actually answer C. Indeed, if we look at the definitions for probiotics and prebiotics from recent ISAPP consensus panel documents, bringing together groups of eminent scientists to come up with valid, accurate definitions, we can see that probiotics are live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. And in contrast, a prebiotic is a substrate that's selectively utilised by host microorganisms, conferring a health benefit. So basically, probiotics are added live bacteria, whereas prebiotics are food for resident bacteria. And these are some examples of foods containing probiotics or prebiotics. And many vegetables are actually sources of prebiotics, although the amounts they contain can be quite low. Now, the definition of a prebiotic, as shown here, does not limit prebiotics to only having an effect in the gut, but that's entirely what we will focus on today. And if we look specifically at the phrasing of the prebiotic definition, it's a substrate. So this means it's a substance as a food source for bacteria that are in the large intestine. It has to be selectively utilised by host microorganisms. This means that it can't be used by all bacteria, but should only be fermented by one or a few colonic bacteria that are beneficial. And it has to confer a health benefit. This is often the hardest part of a prebiotic definition because the health benefit has to be measurable and therefore confirmable. One example of a successful prebiotic is fructooligosaccharides, or FOS. These are growth substrates for bifidobacteria and some other colonic bacteria as well. And they have been shown to improve calcium absorption. So therefore, they have a measurable health benefit. Other accepted examples of prebiotics are shown here. And there are also several compounds that are classed as candidate prebiotics. And these compounds are often candidate prebiotics because they don't yet have sufficient defined evidence of their modes of action and the actual health benefit they can confer. When we think about the mechanisms of prebiotic action, bacterial fermentation is a very important aspect of this. As the bacteria use prebiotics for growth, they ferment them and release other products. And there are actually several options for product formation, some of which involve bacterial cross-feeding. If we think about the production of short-chain fatty acids by bacteria in the gut from prebiotics and other substrates, then you can get direct utilization of the prebiotic or complex carbohydrate by short-chain fatty acid producing bacteria, producing butyrate or propionate, which are beneficial short-chain fatty acids. You can also get degradation of these complex compounds into shorter chain breakdown products, and those can then be used by short-chain fatty acid producing bacteria. Or you can get degradation of the prebiotic substrates by non-fermentative bacteria, say for example bifidobacteria, and this can produce intermediate products such as lactate or even the short-chain fatty acid acetate that are then used by gut bacteria. So these are examples of bacterial cross-feeding, whereby the intermediate products are actually substrates for other bacteria. And these are important mechanisms of action of prebiotics. The health benefits of prebiotics must be confirmed in good, reproducible studies in the target host. The effects can be local effects or systemic effects, and we're going to explain this further in this presentation. Whenever a food containing a prebiotic is marketed, the added dose of prebiotic in that food must be an appropriate dose. It has to be the dose that was tested in the trial. So I'm going to focus on the local gut effects of prebiotic substrates. Prebiotics, undigested in the upper intestinal tract, will enter the colon. And there are three immediate effects that they can have, or three local effects. Prebiotics are a type of fibre, so therefore they contribute to fecal bulking and increased transit rate through the colon. These are important factors protecting the colonic epithelial cells from any toxic compounds that might have been taken in the diet. And they also the increased transit rate makes sure that any such toxins move through the large intestine more quickly, again protecting the gut cells. Bacterial fermentation of the prebiotic causes a lowering of the pH. This helps to inhibit the growth of pathogenic bacteria, which don't generally like to grow in an acidic pH. And the lower pH also improves calcium solubility, and therefore uptake of calcium, and therefore bone health. Finally, two of the short-chain fatty acids that are produced by prebiotic fermentation, butyrate and also propionate, are important energy sources for the gut epithelial cells. This helps gut cell turnover and keeps the gut healthy. So these local effects have very specific health benefits. And I've shown this again here. And the first one of these, the improved gut transit rate and therefore stool bulking, actually has a European Food Safety Authority positive opinion and can be used as a health claim on foodstuffs. The other two health benefits shown here don't have such claims as of yet, but they have definitely got these proven effects. I just wanted to add that prebiotics are not just for use in humans. They're also used in companion animals, again to try to improve health, and also in farm animals, where they are used to promote the growth of the animal instead of antimicrobials. And this is a very important use of prebiotics as well.